let's continue with the resistance color code. So from our previous chapter, from our previous lecture, we said that we have colors 0 to 9 for the first two bands. Then we have 0 to 9 multiplier for the third band, and then we have tolerance. Okay, what is tolerance? Tolerance is very important. It is a threshold that the manufacturer guarantees value. For example, it is a multiplier that it tells us that if we are within 5% tolerance, and if we are buying 100 ohm resistor, within a 5% tolerance, that resistor can be 105 ohms or it can be 95 ohms. So it goes 5% up and 5% down. This is very important because we want to make sure that we are within range of tolerance when we are using these resistors. When we go to the 5-band color resistors, we can reach up to 1% tolerance, which means that if they are selling as 100 ohm resistor, that resistor can be as high as 101 and as low as 99. So yes, it is the process might be difficult, the price will increase, but the result will be better. In our case, in our lab, we are going to be using 5%, so it is still very acceptable. Okay, so we have here we have an example of how we can use the chart to read the values of these resistors. So right here they're giving us pictures of the resistors. In the next slides we are going to see what is the symbol representation, the symbolic representation of a resistor. So right here we have green, we have brown, red, and gold. So from previous chart, we know that green is 5, so it will be 5. Then we have brown is 1. Then we have red to be 2. So we will have 5100. They are using the engineering prefixes to write it as 5.1 kilo, and then they use the lowercase omega to represent ohms. So this is very important. Now, from now on, we are going to be using units to differentiate values, quantities from one another. So if I only say 5.1 K, K doesn't mean anything if I don't put the ohm. So I'm saying that it is a value of a resistor just by the writing the lowercase omega symbol here. And then we have gold. The way we write it up is plus, minus, and then the value of the tolerance. In this case, the tolerance is 5%, so we put plus minus 5%. And then we can continue this. Then we have we have gray, we have red, yellow, and silver. Gray is 8, red is 2, and yellow is let's see what yellow is. Yellow is 4. So here we will have 82 and 4 zeros, but they are putting 1 0 and then they're using the K, which is equivalent to 3 zeros. Here is a typo. This should be 10% because we are using silver, so silver is 10%. Then here again we read the first band is yellow, so yellow is 4. The second band is violet, so violet is 7. And then here black. What is black? Let's go back here, and black is 0. So how many zeros do I add to the end? 0 zeros, which means nothing. So be very careful here, okay? Not to put a 0, because that means you are adding nothing, 0 zeros means you add nothing, and then you put the units plus minus and the tolerance. In this case is correct. Then we're gonna go next. We have brown is 1, black is 0. In this case we do write down the 0 because it is the second band, so the second band we just copied it, and then we have they have, this looks like they put a goal here. We don't have a goal here, so we are gonna take that to be yellow, and yellow is 4. So if this is yellow, then this would be 4 zeros. So take that as a yellow. That would mean it is 4. It will be 1,000. Actually 4 zeros, it will be 10,000, because the brown was, the 1 comes from the brown, this first 0 comes from the black, and then these 3 zeros come from this yellow that we are assuming here, and then we have the gold. So we will have 10,000 ohms. So we can write it like that, or we can write it as this 10 kilo ohms. We can write it as that as well. So we have a couple of typos here, but we are fixing them. Okay. Let's continue. Now we have variable resistors. So what are variable resistors? Variable resistors are resistors that they have from 0 to a value. It's widely known as potentiometers, so they are interchangeably. You can go and say, okay, a potentiometer, it is a variable resistor. Usually resistors that are variables have 3 pins, and this is the internal connection. Without this right here, this alone, it is the symbol representation of a resistor. This is how you will find it in schematics. Okay, this is just a resistor. If you have, it has an arrow in between, it means it is a variable resistor. So what is a variable resistor? It starts from 0 to, let's say, 1,000. So the middle arrow can move to as low as being 0 resistance to be as high as being 1,000, and it can be arranged any place in the middle, so it can hold any value. So these ones are good if we have a high sensitivity toward tolerance, so we can use a potentiometer. In fact, potentiometers are widely used everywhere. Have you noticed when you put your radio, the knob that you move for more or less volume, it is a potentiometer, and what it's doing, it is just letting more or less current to go through. In reality, it's voltage, the one that is playing, but we can see either one, because the voltage is depending on the current, and the current depends on the voltage, so it matters. So another important thing about resistors is that resistors have no polarity. What does that mean? Has no polarity means it doesn't matter the way you connect them. It doesn't matter. You can connect it this terminal, you can connect it on that terminal, and it doesn't matter. There are going to be certain electronic components that we will use later that they have polarity, and it matters the way we connect it. Otherwise we burn it, or it just acts as a open, which means nothing can get through. It's like a switch that it is off, and that is it. Okay, so let's go ahead and stop right here and take and stop here with the resistors.